Okay, so in this lesson, we've been dealing with measurement error. So here we are, our first problem. The depth of a lake is 15.8 meters. Jada accurately measured the depth of the lake to the nearest meter. So that means the nearest meter, what measurement did she get? So if it was 15, if it actually is 15.8, and it's the nearest meter, that means that it needs to be in this place. So of course we look at the 8. The 8 is greater than 5, so that means we round up. So the 15 turns into 16 meters. Next one, by how many meters does the measured depth differ from the actual depth? So it's a simple subtraction problem. 16 minus 15.8. That is 0.2, or 2/10 of a meter. Express the measurement error as a percentage of the actual depth. Okay, well, let's not forget that our measurement error is a percentage of the actual depth. So that means, I like using my percentage proportion here. I know my percent is always out of 100, so that's going to go here. The measurement error is going to go on top. That's 0.2. And it's a percent of the actual depth. And the actual depth is 15.8. The thing that we're looking for is the percent. So we know that we're going to cross multiply, of course. So that means we've got 15.8 times x, and that's equal to 2/10, or 0.2 times 100. 15.8 times x is 15.8x. 0.2, or 2/10 times 100 gives me 20. The opposite of multiplying times 15.8 is, of course, dividing both sides by 15.8. These two cancel. I'm left with x equals, of course, you want to use your calculator, 20 divided by 15.8. You're going to get an answer of 1.2658. It goes on, but we're going to round that. Typically, you want to round, unless you're told otherwise, to the hundredths place. So we're going to round here. We look at this 5. That 5, of course, is equal to 5. So therefore, we're going to round this up. It's going to be 1.27% as our answer. Next, got a watermelon that weighs 8,475 grams. A scale measured the weight with an error of 12% under the actual weight. What was the measured weight? Okay, so 12% under, that means it's 12% less than 100%. So I'm going to do 100 minus 12. That's going to give me 88%. I'm going to, of course, change that to a decimal. I'm going to move that decimal place 2 places to the right. It's going to be 0.88 is the decimal I'm going to use, which I'm just going to simply multiply by the original, because my resulting weight was 12% under. So I'm going to take my original 8,475. I'm going to multiply that times 0.88. And my answer is going to be 7,458 grams. Now we've got Noah's oven thermometer, and his oven thermometer gives a reading that's 2% greater than the actual temperature. Okay, so that means if it's always 2% greater, we know that the original is going to be 100. 2% greater means plus 2, so that equals 102%. I'm going to change that to a decimal. When I change that to a decimal, it gets moved back 2 places. So I've got 1.02. It's the decimal I'm going to be using. So the actual temperature in this particular case is 325. And I'm going to multiply that times 1 because we're looking for what the thermometer reading is. You know, the thermometer reading is always 2% greater. So I'm going to take that 325. I'm going to multiply it times 1.02. I'm going to use my calculator, and I'm going to get an answer of 331.5 degrees Fahrenheit as my answer. Now, it tells us the thermometer is 76 degrees Fahrenheit, and we wonder what the actual temperature is. It's because we're kind of reversing this, and we know that there's division going on, but again, I like to stick to that percent proportion because I think it's far more straightforward. So, we know that percent is always out of 100, and we know what we're looking for is 102%. So we're going to put 102 on top, and we know that the temperature on the thermometer, which is that 102%, is 76. So that's going to go over here. And the thing we don't know is the actual temperature, which is on the bottom. Of course, I'm going to be cross-multiplying. So that means we've got 102 times x equals 76 times 100. 102 times x is 102x. That's equal to 7,600 because I'm multiplying that times 100. The opposite of times 102 is to divide both sides by 102. These cancel. I'm left with x equals 74 point, it's 5098, carries on. I'm going to round that, and again, tenths place, hundredths place, it really doesn't matter unless you're told. I like the fact that this is a 0. That means I can just cut it off here. So that would be 74.5 degrees Fahrenheit. Next problem. The beginning of the month, there were 80 ounces of peanut butter in the pantry. Now, there's 1/3 less than that. How many ounces of peanut butter are in the pantry now? Okay, so this time we are going back to dealing with fractions instead of percents. So we know when we have the fraction, and it says 1/3 less, then I'm going to be taking my 1 whole, because that's the whole entire thing, and I'm going to be subtracting, because it's 1/3 less, 1/3 from that, and that's going to equal 2/3, because it's 2/3 that's left. So my original was 80, so I know that I'm going to be finding 2/3 of 80 to find out how much is left. So to find 2/3 of 80, I'm really just going to multiply, so it's 2/3 times 80. So let's see, well, look at that. A is exactly what I have right here. Let's look at the others to see if there are any others. 1/3 times 80, well, that's how much was eaten. So that's not 1. 80 minus 1/3, well, that doesn't make any sense at all because it doesn't say that 1/3 of an ounce was eaten. It says that it's 1/3 of the original, so this doesn't make sense. This is 1 plus 1/3. We know it's less, and that's why we subtracted, so therefore it doesn't get larger. Although that would be very cool if I could put peanut butter in the closet and I'd take it out and there were more. But it doesn't work that way, so I am going to cross this one out as well.